Test 1 2 1 2. Okay, we have sound. Let's see if we have shot. And yes, we have shot. So good evening, everyone. Good morning, good day, good afternoon, good night, good whatever. So welcome back to my stream. I miss you guys. So today we're gonna do some stuff. So as I said on my past streams, I want to thank to Lab 4450 to sorry, I have a blank, to help and assist and collaborate with me on this stream. So I want to thank them. They are a Portuguese online store of 3D printed stuff, 3D printer stuff, mostly hardware, high quality stuff, good prices, good people. So if you guys need some stuff, take a look around, link in the description. And I believe in 2 days he's gonna be adhering to CLE Day, and he's gonna have some good discounts. So if you guys need stuff, go there and check them out on the 25th this month, so in 2 days. And well, check them out. So I'm very happy with my machine, and I'm having a problem with it. It's not a big problem, but it's a bug in the macros, and I think we're gonna start with that because I want just to get rid of that, and I'm pretty sure I found out the problem. So I think we're gonna start with that. Boas, Vini. Boas. So então, e essa velta? Tá quase ou não? So Bini is building a velta. I'm gonna start soon as well. And so the thing with the Tridex, I'm having a problem with the swap method. So this thing can change heads when printing. Okay. And there are two modes. The classic mode, it's the slow mode. Basically, it just moves one tool to the side and calls the other to start print. And the swap mode, it's a faster thingy. Then it just moves immediately, it swaps heads. So I'm having a problem with that, and we're gonna go through the macros to check that out. I'm pretty sure I found the problem already. Oh, I know where is the problem, but let's gonna move through the macros and debug it like I did, so you guys can see my process. I'm not, I know how to program in Java and C++, but I have no idea how this thingy Jimba or Jinja or whatever that Clipper uses. It looks like Python, but I don't know Python as well. So I can understand the written code. I can understand what it does, the instructions and whatever, but I don't know the instructions if I want to do something myself. But we're gonna go into that, and we're gonna start with that. And then we have, as I said in the streams, I bought some cheap camera to try to do the nozzle alignment. I got the camera, it's this thingy. See, it's very small. And RGB LEDs ring. And I designed a case for it with magnets. I'm sorry, I already put the magnets because I already did it. We can go through the CAD how I designed this, but this is pretty simple stuff. We can go through it. And this is the controller for the LEDs that comes with a remote. This thing came with a heat shrink around the PCB, just like that, but I already removed it to see the size of the PCB, so I can make a spot for it on the box. But yeah, we'll talk about it later. And yeah, let's go through it. So let's gonna start with the Tridex. So first, let me show the problem. So I still have my jumpy camera, but we're gonna have to deal with that for a while. So let's see the problem. Okay, I have my crosshair there that we don't need. Let me disable the crosshair. Disable the nozzle. And okay. So the problem is simple. So I'm gonna home it. Okay, maybe I should do another thing. Maybe I should share my big screen. Yeah, there. That should be fine. So we can have clipper. Let me. Okay, we have like that. Let me reduce it a little bit. Like that. For now, should be fine. So I'm gonna home it. Oops. I only own Vex, which doesn't really matter. Well, actually it does. M18. Let me move the heads away. Let me home all. So let's home all. So we can see the problem. Okay, so the problem, if I do a tool change here, we don't need to calibrate to Z-tilt, so if I do a tool change here, it works fine every time. No problems. So now let's move it 2 millimeters. So I'm going to move the orange at 2 millimeters, 2 millimeters to the right. 1, 2. So now I'm going to do tool change again. So when I do tool 1, it's fine. But when I do tool 0, I get an error. So I get an error out of range. Okay, so here's the first problem. So we know we have the problem is on the change mechanism. Let's call it that. So in the change macro. So let's go into the machine. So these macros are on IDEX mode. So we're gonna take it lower. So yeah, so in the problem is when we call T0. So we have this first macro T0. So the problem should be in here. So you guys see my mouse? Yeah, I don't know. So here we have T0. So description, activate T0 in full control or auto park. G-code, so here we set the macro variables. Basically we're gonna get from the file the macros from a file, which is on this variable, and the variable it's in here somewhere. Here, save variables. So it comes to take on this file the variables. So here tweak Z offset, so this doesn't matter. Do scrub, so this will scrub the nozzle if the variable is on. Hi Joseph. Nice to see you. I'm gonna solve the macro now. I'm pretty sure I know the problem already. So Joseph in here in the chat is the guy who actually made the macros, and I've been talking with him about this last night, and he helped me understanding and how to do some stuff with this language that I don't know. So yeah, so I'm just explaining the debugging process that I went through, Joseph, that actually we went through yesterday. So we know the problem is in T0, and so this is the scrub stuff. The carriage, dual carriage is defined. This doesn't matter for our problem. This is if we are calling the T0 and it's inactive, you're gonna do stuff, and it is, because when we call T0, the T1 is the one that is working. So then it's gonna check if the printer is zoomed. If it's zoomed, then it's gonna do, and I'm gonna activate the extruder, set dual carriage, whatever. Blah, 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 blah. So here, swap to heads. Hey Jack, welcome. So here. So here, basically, it's going to identify what is the tool change method we are using. If we are using the swap or the classic. So basically, it's going to check if we have the swap enabled, and if we do, it's going to do it's going to activate the swap change. So it's gonna write swap change. So if we check, now is the part, well, maybe I can do another one so we can, yes, I think we can, yes. So as we see, it does actually, when we called T0 here on the console, it actually responded to swap change. So it means that we got to that code, and then it gave the error. So it means this thing here actually happened. Boa, Simão. Welcome, Simão. So it means this line happened because this just types in the console swap change, and then it calls the macro swap T0. So, and then it basically ends. So we need to check, the problem should be in swap T0. Actually, it is on swap T0. So we need to go to the macro swap T0. And I have this here. This is the original one, because I don't want to mess with the original one. I just made a copy, and it's in here with the debug activated. Well, not activated, just an information that's a debug. This is a comment. This doesn't matter. You can write everything you want here. It won't mess with anything because it's comment. Everything green, it's comments. So here performs the tool add swap. So there's where we have the problem. Here it sets a bunch of variables. So this is a variable. You can call it whatever you want. And this one T0 current position. That's what it means. So it's gonna get where T0 is right now with this code. So it basically gonna go to Clipper printer config file, config stepper X position. Okay, so since we are calling T0 means the T0 is parked. So this basically it's the parking position. So it's gonna get the parking position of the head. It's on the T0 in this case. It's in the beginning of the x-axis because it's on the left. So it's gonna get the end stop. Boas, Cristiano, bem-vindo. So it's gonna get the end stop position, which is 0 because actually minus 50 on the Tridex. So that's what I have in the configuration. We can check if you want, but it's minus 50. And the parking position is set by another variable. That's the distance from the end of the axis. There's a variable that I have set to 1 in my case. So that means in this case it's going to get the printer X position end stop, which is minus 50, and it's going to add 1 because it's 1 millimeter from the end, one end or the other. In this case it's the beginning. The beginning is minus 50 plus 1 is minus 49. So it means the park position of T0 it's minus 49, while the park position of T1 it's in the end of the x-axis. In my case the end is 304.5 millimeters minus 1 because it's 1 millimeter from the end of the axis. So it's 303.5 for the T1, the parking position I mean. So if we are calling the T0, it means the T0 it's on the parking position and the active one it's the T1. So T0 it's on parking position, that's fine. We can check these variables. I'm gonna explain now. T1 current position it's where it is now, and we can check that in here. So it's in 125, and actually I'm going to move it to, well, it actually was in 127, but then it gave the arrow, so it doesn't matter where it is now. But it was 127. So it's gonna get the position here, printer G-code move G-code position X. So basically all these things, it means it's gonna get the X position of where the T1 is. So then this is the T0 new X. So this is where the T0 is supposed to move to when we actually do the swap. So it's gonna be as T0 will replace T1. So the new X position for T0, it's the actually current T1 position. So that's why T0 new X equals T1 current position, because they're gonna swap. So T0 is supposed to go where T1 is right now at this moment. Then T1 new X, this is where T1 is supposed to go. So it's supposed to go to the park position. As we said, the park position is the end of the axis. In this case, it's gonna go to the config file and get the position max we have set on basically it's the max limit of the dual carriage. And it's gonna take the park distance, that's 1, so it's gonna be 304.5 minus 1, so it's going to be 303.5. So then we have T0 distance. Basically this is the distance, the total distance that T0 will have to move, and this is the total distance that T1 needs to move. So basically it's the T0 new x, so the where it's supposed to go minus where it is right now. So it's how we calculate the distance, right? So we subtract the where we are to where where we gonna go to where we are, and we get the distance, right? So that's the same thing for T0 and T1. So we can check these the value of these these variables using this command. So respond message, basically it's gonna send a message to the console with all the data. So this part here, it's whatever we want to write. We could write everything, anything we want here, a string, and this between the brackets, this is actually the value stored in the variable. So it's going to be a number. So this was something I didn't knew how to do, and Joseph helpfully taught me how to do it. So here we can do this, and we can check every variable here. So we can actually do the math by ourselves and check if it's doing what it's supposed to do or something is wrong. Because when we are programming, it's very easy to program something that actually it's easier to program something that we don't want it to do than actually program what we want to do. So because there's only one way to program it, what we want to do, and all the other ways, it's not what we want. So yeah, we can do this, and if I just save and restart here, now we're gonna see some values showing up here in the console in a minute. Yes, exactly. So we're gonna home again. Yeah, that's what I said, Joseph. It's very much easier to do what we don't want to do, or actually to program something to do not what we want, not the thing we want to do, than is to program the thing that we actually want to do. I speak by myself, so okay. So we ohmed it. So it's gonna move it 2 millimeters to the. Actually, I was looking to the wrong because we are concerned about the x. Move 2 millimeters there, and now we're gonna change T1. Shouldn't be a problem there. The problem is when we call T0, and see, we have a bunch of stuff here. So we did the swap change, okay. We did the T0 current position, it's minus 49. As I said, it's minus 50 plus 1. We have the T1 current position, it's 127. Let's ignore this bullshit. So that's the current position, that's fine. The T0 new position is 127 because we want to swap T0 to where T1 is, so that's fine. And the T1 new position is the park position, so it's 304.5 minus 1. That's 303.5, so that's fine. So that means T0 is going to need to move 176 millimeters, while T1 will need to move 176.5. So we are good here. So let's get back to the macro. Actually, yeah, I should have left. I don't know what happens when we have two windows open, but doesn't matter. So we can check it when we need. So let's go back to the IDEX mode. Okay, so we were checking this guy here. So we were here. So now what happens? So how the swap mechanism work? It's basically it's gonna act like it's copying the axis. So that means it's gonna tell T0 to move along with T1 like if it was copying. So why do we need this T0 distance and T1 distance? This is to make sure that it's two things. First, to check if we can move all the way until the end of the motion, or if we passed the limit. So that's the first thing it does. And then to make sure that it's gonna move the smallest the smallest distance first, and then finish the longest. So in this case, we have that T0, let's check. So T1, it's bigger than T0. So in this case, if T0 is bigger than T1, it's not our case. In this case, if it's T0, it's under T1, so it is minor T1. So this is the case we are in. So this is where this problem is. So now, where is the problem exactly? Well, we don't know. So what I did was just put test points. So just throwing messages to the console. So if the code gets here, it's gonna write TP0. The TP is from test point. This is a trick I used, not a trick, a method I used when I first learned programming. So if TP0 gets in the console, that means it got in here. So then it's gonna do this. So this is gonna set the carriage 1 to mode copy. Now I understand what this means. Yesterday at the beginning, at least I didn't, but now I do. So I had no idea what this was doing. So, and you may not know, so, but you don't care, because maybe this is not the problem. So then I'm gonna do another test point in here. So if I get this TP1 in the console, it means it went through this with no errors and posted TP1 on console. So then this is the, oh, actually, this is for later. So then it's gonna do this. This is not original from the code. This was me who put it here already. So then this is the next line in the code. So it's gonna do a G0 X. So a G0, it's a fast movement to where? To X, to the new T0 new X. So it's gonna move something which it's going to move the carriages, both of them, because it's in copy mode, the amount that it's in T0 new X. And F means feed rate, so this is basically the speed. Then this is not from here as well, but leave it here. Then I'm gonna do another test point. So if we get to test point 2, it means it passes everywhere. Then set dual carriage mode to primary. So it's gonna set the dual carriage, it's the second head basically, to primary mode. So it will move actually that head alone, not in copy mode anyway. So it's gonna do G0 X2. Well, actually, before I said here it was the amount, but it's not amount, it's the destination. Hey, Peter, Maggie. So this is the destination. So it's gonna move T1. Since T0 is smaller than T1, when we move T0, when we move even in copy mode, the distance T0, since T1 to T1 distance it's bigger, it's gonna need to finish the T1 because the T1 it's not in the end already. So this is what this part is gonna do. It's gonna finish moving T1. Because when you do copy, if one has to move 176 millimeters and the other has to move 176.5 millimeters, if you do a copy move of 176, the second head that it's still missing half a millimeter. So that's what this second part it's gonna do. And we're gonna set another test point in here. So it's gonna be the test point 3. And then it's gonna set since now the heads supposedly are swapped, that means the move is done. Oh yeah, that's past bedtime actually for you. Thank you for the visit, man. Stay in touch. You have a nice trip. So that's fine. That's fine. Sleep well, my friend. Sleep well. Get some rest. So okay, so that means the swap it's done. So now the only thing left to do is activating the tool 0 as the primary one. So that's what this command here do, and activate the extruder from that head. So now we're gonna try again, and we're gonna get more information where the error is actually occurring, because when the error occurs, it won't print any of these test point messages. So let's save and restart. Okay, these actually sync. So maybe I can do it in here. Yes, I think I can. So let's do another homing. So I went through all this process last night already with Joseph, and we figured some stuff out, but today I actually thought about it because yesterday I was very tired, and I think I know the problem. So okay, so now we're gonna move 2 millimeters to the left again. So we're gonna go to X127, and we're gonna do T1. T1 shouldn't be a problem. And now we're gonna do T0 and latch the console. Okay, so we have all the variables again, so that's cool. And we see we have TP0 and TP1, so the problem is after TP1. So let's go again to the problem, to the configuration file, and let's see what's after TP1. Swap T0, I think I passed, yes, it's here. So we have TP0 here, so that's fine. Then we have TP1, and then we have the error. What's after TP1? It's this one. So that here is our problem. So now, to check the actual problem, we're gonna need to check what's in T0 new X at this moment here, before it does the movement. Supposedly it should be 127, right? Because if we go here, T0 new X, it's 127 point blah, 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 blah. Doesn't matter. It's 127. So let's do the feed rate is not a problem because our problem is an out of range error and not too high speed or too low speed error. So something should be going on here. So with this command here, we're gonna check what it's actually doing. It should, remember, it should be 127. So let's save and restart again. I know this is boring, but this is how it's supposed to do, unless you are a more advanced user and you know more stuff and you know exactly where's the problem. But this is how you debug point by point, just doing every step on the way. So we're gonna home it again. Okay, so let's move 2 millimeters to the right, sorry. Let's call T1, and now let's call T0, and why is it? Okay, so we have the 127 as expected, but check it out here. The problem was it's trying to move 127.81, not the 127 they should. So where did this 81 came from? Well, you guys don't know, but I know that that number, by pure coincidence or not, it's exactly my T1 offset value. So it's moving actually the 127 millimeters plus the offset. So here's the problem, because it was supposed to move 127, not 127.81. So what that means? That means that when we do the distance evaluation, so when we do the T1 and the T0 distance, though that math is not taking in consideration the X offset, and that needs to happen because otherwise this should work. So we found where is the problem and what actually is the problem. So we need to go to IREX mode. So we found out that here, no, not here, here. Here, instead of moving to 127, it's actually trying to move to 127.81. So that means if we do that, if we do the math now, with those extra 0.81 millimeters, the T1, it's actually bigger. Well, the T0 distance is actually bigger than the T1, and that's why this is taking a mistake. So in my opinion, I think here on the T1 distance, I believe. Now I know the problem is here, so the solution exactly I don't know. I know we need to take the offset in consideration. It's either a plus 81 or a minus 8, not that 81, because we're gonna actually use the variable. Because if we use the number 81 in here and later we change in the variables in the offset the after the variables are set, you can add a set G code offset. Yes, I can, but that I think I think the right approach in here it's just taking the offset into consideration. Because yesterday I tried to actually in here subtract the offset, and the coordinates were getting wrong by it was working, but it was not working right because it was moving to the wrong places. So I think if we take the here the offset in consideration, basically we need to I think we need to have here plus, so now I need to come here and copy these DC vars. So this is how you get the actual value of the offset that you set, DC vars point offset underscore X. So if I put it, it's either a plus or a minus thing. And because T minus, so we need the T1 to be, no, I think it's minus. Because we need to do the actually value, it's lower. We need to get it lower. I think it's like this. Let's save and restart. Now let's home. I should have done other thing. Okay, so because now supposedly at 127, when I call T0, well, see, yes, when I call T0, it shouldn't appear here any, at least at 127, it shouldn't appear here any TPs, because it should not enter in the second if, it should enter on the first one where we don't have the test points. So let's see, I'm gonna press T1 and go to the emergency stop. No, actually it doesn't. Oh, no, actually I need to call T0, not T1. Okay, so that's yeah, it didn't come in here because now it's as it's taking into consideration the offset. See, we have T1 distance, it's lower than the T0, so we need to move another millimeter actually. So at 128 now we should get into the second zone where we were before, and it should work. If I'm right, it should work. So I'm gonna call T1. Let me check one thing. Yes, that's fine. And now T0. See? Now it works. Now let's move it more to the end of the axis to make sure it's working. T0. No, T1. Okay. And now we should be with, yes, we are. Now T0 again. Okay, it looks, it's working well now. See? I think that was the problem. Now, what I'm gonna do, I'm gonna try to do the same thing but on the other side. So let's try, not that much because I don't think, let's do it like that. Let's call T1. So it's working fine. Let's call T0 again. And I think we are good. I think we are fine now. What I want to do, I'm gonna do a firmware restart so I can do the ohming again. Yeah, I think you only need to add that line to the macros. Now I just want to make sure that the coordinates are right. So I'm gonna do ohming again. Just see if we are not getting lost in losing movement somewhere. We shouldn't, because we are not actually setting the... Well, actually, I don't know. Let me check one thing. Because I think T0 distance, it's only for the distance evaluation, so we are not actually messing with any... Yeah, exactly. We are not messing with any movement at all. We're just evaluating the amount of movement and which head will have more or less movement. So we are not messing with movements at all. We're just evaluating the distance that each head needs to move. So yeah, I believe this is the solution, or at least the easier solution. You just need to add this to the macro to make sure it's fine. But so did I own? No. Let me own it again. Okay, so we are just concentrating here on the value on the tool 0, because the tool 1 will have the offsets on. So let's put it here. So if we swap to T1, we should have a different value here by 0.81, either one way or another. Not here, in here, yes. So this is the relative coordinates, and these are the absolute. So now I'm going to change to T0 again. Yes, we are fine. Now if we change to T1 again, and if I move wait, why do I have... Why do I have here? I shouldn't have this, right? Okay, now I got lost. Oh, because I'm on... No. If I get to T0, what do I have? Huh. Okay, I don't think this is right, because this value shouldn't change. Okay, maybe I'm wrong. Or maybe we have to... No, but the T0 shouldn't have anything to do with the... I don't think this is right. Let me just omit again. Okay, in here, If we call T1, that's fine. If we call T0 again, that's fine. Well, in the apps, well, we can do, I know what we can do. We can stop this and we can assemble the nozzle camera, and we can use the nozzle camera to actually check what's going on here. So if we call T1 again, and if we call T0, we call T1, call T0. Okay, yeah, that makes sense because the okay, let me move to where we know that we have a problem, something like there. And now let me go T1. Yeah, I don't think this is okay. And the main, let me check the code again. Yes, yes, I tried to do that yesterday. Well, we can try. We can try to check that, but yeah, I'm pretty sure I tried that yesterday. So let me just see if I don't have. No, I don't have. No, it's not here. It's here. So new X. This is not. Yeah. So let me remove the this thingy here. Actually, I'm just gonna Control Exit and Control V here. Save and restart. And change. It's IDEX variables, right? Yes. Nope. It's not in here. It's in IDEX mode. So here, variable park distance. So this is the one you're. Let's increase it to 2. I think this will solve my problem at 127, but if I increase it to 128 or 129, it's gonna give the same problem, I think. So let's go. Well, I'm thinking because that makes sense. We are actually, well, that makes sense. But I believe we actually, the problem here, it's not, it's another one. We did that on the swap T0, but we have to do actually the same thing on swap T1 to get the. I think that's what we are missing. We need to change the math on, because the math is it's the same. We need to change the math as well on the T1. So let's see. I think there's no problem here on 20. If I do the 27, let's call T1 and let's call T0. Yeah, exactly. But if I get to, let's, to 29, I may be wrong. Well, maybe. Well, maybe you're right after all. But I know I tried these yesterday. Well, maybe I'm wrong and I didn't try it. Or maybe I thought I tried it and I didn't try it. Like I changed something else. Sure, man. I really appreciate you did all this work. So, and since I work with CNC machines and I do macros of my own on CNC machines. When we fuck up the macros in CNC machines, it's not the same thing as fucking up macros in the 3D printers. Because if this thing crashes, the steppers will skip and whatever. It sounds ugly, but nothing really catastrophic happens. Maybe a 3D print parts, 3D print part breaks or something like that. But there's not a really big issue on big CNC machines. Shit gets expensive really fast. So when I do my macros on CNC machines, I really like to try all scenarios and check if every single possibility it's working well before I can be actually with peace of mind and using that macro. Before I need to test everything I can remember, I even do some list on a notebook. I tried that, I tried that, I tried that, I tried that scenario. If the head is here, it works. If the head is there, it works. If it's on the side, it works. If it's on the underside, it works. That's why I actually found this problem, because I was trying. Well, actually, I found the problem with the print, but after the print, I went to okay, if this doesn't work on the print, that has to be a problem here somewhere, and let's try to find out where the problem is. So then I tried to simulate the problem without actually printing. Now what I'm really not disappointed, but disappointed with myself, because I could swear maybe I only saved, I didn't restart, but I'm pretty sure I changed that sync to 2, as you even yesterday asked me to try, and it gave me an error. Maybe I didn't save. I only no, not saved, not restarted, because now it's working. Let me try on the other way, on the other side. Maybe a little less. I don't know if the etching gets there. Yeah, it's working. Well, I'm sorry for losing your time, but that thing actually works. Maybe not. Yeah, the ads are not absolutely in the wipers where I would like it to be, but they are good enough. Yeah, they are good enough. But looks like it's working. So if the ad is there, it's working. And on this side, hey, Vini, it's the same thing. The on other printer, as long if it has the same mechanism, only board, if the board is different, only pins and number of stuff changes. If you have the same motion, it will be the same. If I did another printer that was a BMS printer with the same system, Core XY hybrid, how they call them. And only the printer configuration and maybe the build size changes, but the macros would work just as well. Yeah, and I really appreciate your help, Joseph. You're an awesome guy. If you check the streams, I mentioned your name a bunch of times, and I really appreciate the work you put on this, because when I started building this machine, what really bothered me was the firmware. The firmware was mechanics. I have no problem with mechanics. One way or another, I'll deal with it. But when it's come to software, I was very, very, very afraid because of the specific clipper branches and whatever. And when you said you had the macros, it would work with regular clipper, I was like, oh, thank God, a huge weight out of my shoulders. So I really appreciate your work on this one. Yeah, but the bad you just need to set it's just physical stuff. It's just the either the pins of the board, the position of the end stops. It doesn't. Yeah. So yeah, I really appreciate your work in these macros, because this was much easier than I was expecting. A few hiccups here and there. That's fine. That's normal with all my printers so far. So yeah. So actually, well, we learned something. We learned how to debug a macro, and yep. But that's the same on every printer. It's just not on. It's not even on the Tridex alone. You need to do that on every printer, whatever it is, on every CNC machine actually, unless it has servos with absolute position. That's the case on mine. My CNC machine only has hard end stops. Well, not hard end stops. It has end stops, but they basically only work if something goes terribly wrong, because the offset macros. No, I haven't needed the offset macros. You mean the macros to set the XY offset on the fly on the printer? I haven't tested that because I didn't need it. Since I used the camera to align the nozzle, it was perfect. The very first print I did, it was spot on with both colors. So I didn't need to mess around with with the offset macros. I assume they work. They should work. So, but I didn't need it. And now I'm gonna build. It is. I can tell you right now, Vinny, it is possible as long as you modify your Mercury into the same movement type, like 2x to an hybrid core XY, which I don't agree with the name, but it is what it is. So you get the double Ys and one motor for one head, the X on one head, and the other motor for the X on the other head. I can assure you right now it will work. You only need to put some hours in the CAD and start messing with it. The work itself, that will be, it will be a pain. I can help you if you need, but I can assure you it will work. So as I was saying, we're gonna do now, I think, Joseph, you have one of those Ember prototypes cameras. And I found out that, well, actually I'm gonna build one myself now, and it actually works with the software of the Ember prototypes, because I tried it just connecting the camera to the USB, and it works with their software. So I assume they are using exactly the same camera. Mine just has some upgrades because I know the Ember prototypes have six LEDs on the camera, built in on the camera. And actually when I saw the PCB, I don't know if I'll be able to show it in here. So you guys see these holes here on the side. So this is actually weird for me. So here there's 6 holes, and on that side the same thing. And on the PCB actually it has a symbol of a diode. So I think they are actually using these PCBs with these cameras, and they are soldering the LEDs in there to give light, but you don't have control of you can't dim the light, they are just on, same power all the time. So I just decided, but when I first bought this camera, I didn't knew that we could actually add the LEDs there. So what I did, I also ordered a ring of LEDs, and these actually are remote controlled with this board here. And yeah, we're gonna assemble this thing. I just made a case for it with magnets on the back. I think the Ember prototypes also has magnets on the back. I'm not sure. Yeah, mine is bigger, but since I have to put the board, the LED board here, and the ring, it's actually a big ring, so I needed the box to be at least the size of the ring. So yeah, let's go into that, and we can test it since we have the machine working. We can test it after. So let me just orient the camera. Okay, let me change camera so I can see what I'm. Okay, looks fine. Looks fine. Okay, so what do we have here? Oh, so, well, we can check these later. These are some tests I have here for the Velta. So I need my iron, it's on. Need this, I need the and I need to turn on my press. Okay. So first I'm gonna desolder this wiring that came from the factory because let me maybe zoom in a little bit. Okay, not that much maybe. Yeah, something like that should be fine. So I'm gonna desolder. Yes, we have labels, so there's no problem. I can just desolder it. Oh, let me grab the soldering iron actually and put it here. So I'm gonna use blue for data, and I need to check how much wire do I need. So this is supposed to come here, and it has a window to have access to the wiring. Okay. So this comes here when we want. You don't need much. Yeah, something like this should work. 5 centimeters or so should be fine. We're gonna use red, same size, and black. And I need my wire stripper. Give me a second. So I'm gonna thin the wires first. Okay, Beanie. See you later. So we're gonna go red is plus as usual. Data is the blue. And black is ground. So now I can actually press this in the way I did this model is to actually be a press fit. And it turned out very nice. Okay, I can strip here. Now, if I could get 5 volt here somewhere. Well, actually, we have a bunch of. Well, we can actually. Let me grab my multimeter. So, let's see. So we're gonna need to connect the USB cable. So this is the original USB cable, but besides being short, it's very hard, the wiring. So I'm gonna rewire. I usually buy these USB cables. These are from gaming mice or mouse or whatever you're gonna call it. And these are very soft and very long. These have like, I don't know, more than a meter, maybe 1.5 meters. And I really like to use them. So these are cheap. They cost like $3 or something like that. So these are really nice. You need to recrimp the connector, but you can't have it all. So okay, so what I want is I want my USB cable in here. Since we need to provide power to the LED board, what I want to do is to check if the plus connects to some of the available. So let me set the beeper. So this is the plus. Oh, it's right, the first one. Okay, let's see the ground. The ground, it's the Ford. It's the last. Okay, so we have. Let me try to show this. So if I go to white, so on this board we have 4 let me give it more light. Okay, so we have 4 connectors there on the side of the USB connector. So the first one is a square pin, it's the plus, and the last one is the ground. So we can use that to actually connect the LED PCB. That's cool. So if let me grab some heat certs, I need to, and some screws. since I need to screw in the so we have 3 and I need some M3s force. Should be fine. 5 should work as well. So let me use my stealth press to press in this inserts very fast. Just 3, so give me a second. I'm not even reposition the camera for it. Pretty sure everyone's seen pressing it set a bunch of times. That, and we need the other one that fell off. I'm gonna actually press this a bit more in than usual, just to make sure that the metal from the heat set doesn't get into the PCB. Shouldn't be a problem because there's nothing nearby the screw holes, but you can see they are not flush. Actually, I pressed them down further. I could have just add like one, I need the 2mm wrench. 1 screw and 3 pins would be fine, but I always like to overdo stuff, so. Well, actually, I'm not. I need to solder the wires first before. So the USB goes there. So let me check the size for the wires. So this thing goes there. Yeah, just something like this should be fine. These are soft, the box is big, we have plenty of room. No point yeah, that's fine. No point of cable management, don't need to be the best. As long as the wires get inside the box, we should be fine. Okay. So let me add some flux in here. I'm gonna add some solder to the first and the last. So the square one, it's the plus. Okay, maybe I shouldn't add the solder just yet. So like that, and we have the other one, it's the ground. like that. Now I can desolder all these guys in here. Plus, do we have, yes, we have information of the wire positions, so we are good. So top one it's plus, third one it's data, and that's ground, which actually has too much solder. So the ground is this one. Like that. Data. Come on. Like that. And plus need some weight on top of the board. Like that. Okay, and we have plus and minus flux. Let me grab my tweezers. So minus goes there. And plus goes here. That's fine. So now all we have to do, no, actually now I'm gonna try to, I didn't check, so I received actually these USB cables today. I had one more, but this looks a better option for here. So I want to try to get the rubber thingy in this little hole. I should have done the hole bigger, but like I said, I didn't knew that these were coming in today. So I'm just gonna try to reshape the rubber to my wheel. Since the rubber is very soft, I think I can just push it. If I just trimmed it a little bit, I think with a little screwdriver. Okay, I need to cut the connector. We don't actually need the ground wire. Oh, doesn't matter. Let me see if I can push this thing in here somehow. No, I think it's too big still. Let me grab a small screwdriver. What is it? Should be here next. Oh, here. Let's see if I can persuade it to go where I want it to go without breaking the printed part. I'm sorry, I won't be able to actually go because I can barely see myself. Oh, maybe. It can be done, maybe. Oh, already scratch it. I don't think that's a big problem. Okay, I think I need... Yeah, I need to trim it. Let me remove this. I think I need to trim it a little more. This is way too big for what I want to do. Yeah, now it should be doable. Okay, let's try again. This big thick part first. So I'm pushing in as long as I'm... Let me grab a bigger... Go there. And also try not to damage the actual cable. That's kinda important. Okay, that's about 75% done. Yeah, I think... Yeah, it's done. That's fine. So I actually got the rubber thingy in here. Okay, now I need to... Now it's the worst thing. I need to... Where is the cable? The original one. I need to crimp this stupid little... It's not little, it's micro connector. I'm gonna need this guy, maybe this guy. I need the box. I think it's one of these. These things are super duper tiny. I'm probably gonna need my magnification glasses. I think. Yeah, it's this one. And I actually need to... Well, actually I'm gonna... Okay, this is so small, and I kinda need... I should have another cable, since I use these cameras all the time. Well, I'm gonna do the connectors. Jesus. Okay, we need 4. it's a 5 connector, but we only need 4. These things are super tiny. I mean, can you see it there in my hand? Let me put CNM3 screw next to it. Yeah, I'll need my crazy scientist glasses. Where are they? They are not there. Oh yes, I was sharpening a drill. Yeah, it's here. So I use these thingies. I actually need to take off my seeing glasses. I love these thingies. The only thing I don't like is I need to be stupidly close to actually see something. So probably my head will be on the way. Okay. I don't even know where. So they should be on the last one. So these things crimp actually on the last position of these pliers. Is it good? Yeah, I think so. Well, to be honest, I think it should be even smaller. I don't know. So black. What I know is I managed to crimp one, so there's 3 to go. This one is fine as well. This thing is super small. Jesus. Okay. It's in position. Okay. Yeah, I have a feeling it should be even smaller than the last one, but it's working good enough. It's not the first time I crimped them anyway. Don't even... Yeah, that's smaller than this one. So we need the red and the white. I'm gonna strip them both now. Like that. Okay, one more. It's gonna be the white because it was the first I got. Come on. Damn it, I lost it. And these things are so small, I actually need to grab them first on the plier. Okay, I have the back, the actual cable tabs to close, and I can't. Yeah, now it's good. Oops. That one is gone. Yeah, I ain't scared of this shit. I do everything. I do everything live without preparation. Cause let's be real, shit happens when we do that, so if we are prepared and shit happens, people will never know, and when shit happens to that people, they will be like, wow, what now? The guy on YouTube did it so well. It went all everything right. No errors, no lost connectors, no nothing. At least this way, if I have a problem, people will see I have a problem, and I'll solve the problem, or I'll try to solve the problem. And if I solve the problem, people will see how I solve the problem. Because let's be honest, people only come to YouTube to find solutions for the problems. Well, of course, we are seeing stuff well done as well, but mostly when we're gonna search for something, it's gonna be, oh, okay, I have this problem, let me see if someone else had this problem. And if we are prepared and done the hard stuff actually before, where's the fun on that? That's why I like Steve builds, because Steve It's kinda okay. He does way more preparation than I do, but it's kind of the same way. Well, people may argue, oh, but you do long videos. Well, you can get it all. If you want to see the solutions, you have to see the videos. Actually, I forgot to do the second crimp on this one. Oh, I see a wire there. Don't like the wire there. Fuck. This white wire, it's pissing me off. Let me finish the red one before the same thing happens to the red one. Well, and I appreciate that. And I appreciate that, Joseph. I really do. I mean, I'm not here like... I'm just here. I don't mind if no one's watching. Of course, I prefer people are watching since I'm having the trouble to record what I'm doing. Because basically it's what I'm doing. I'm just recording what I'm doing. But yeah, and I appreciate some people actually understands why I do it and actually appreciates it. So I appreciate your appreciation. And I'm sorry I can't really show what I'm doing, but I can barely see what I'm doing myself. I actually need to strip a little more of this guy. I should have set up the microscope to do this. And yes, I do have a microscope because I actually also do microelectronics, laptop repairs and stuff like that. I actually love to do that. Maybe I'll do some streams about it as well. Yeah, now we're good. Yeah, that's fine. Okay, so now I can drop these guys, I think. The crazy doctor glasses, like my goddaughter calls it. So, red first. So red, white, green, black. Red, white, green. I'm gonna try to use the same plastic connectors because my box is getting low on those. So red, white, green. Red, white, green, red. Is it on? I think so. Right. Green. Come on. Cooperate with me just a little bit. Yeah, green. And black. Like that. So we should be fine. Let's try it. Well, let's finish it. I don't care. Should work. So this connects in here like this. Probably something like that. That can go away. Yeah, that looks fine. Let's put a screw in. Like that. Let's put more screws in. And where's the other one? It was here. I know it was. It went to the floor. I didn't hear it. Well, guess I need to grab another one. Okay, I'll grab another one. Doesn't matter. I have so many anyway. It will show up. Oh, it's there. See? We just need to stop looking for the stuff and stuff show up. Okay, so we have three screws in. I haven't put one there on that one because it's too close for the too close to the connector, so I actually did only the a pin. So now these should fit. Should. Actually, I'm gonna put it like this. This is the first time I'm actually trying. and it's not looking great, but I'm confident on my CAD skills. Like that. And this wire should have enough space around there. See? So we are good. Actually, we're gonna try to put them here on the back. We are good. So let's YOLO it and put some screws in. So these are Phillips. Oh, I need 4. I only took 3. These are Phillips screws. So let me grab a Phillips driver. Could be here somewhere. Is this good? Could be better, I think. Let's see the plus one. Yeah, that's the one. Okay, I'm not very happy with this gap, but it's fine. It's fine. Let's see. Does it screw in? It screws in. I only put, well, if I'm putting 2, why not put them all? We are feeling lucky anyway. So first time I spoke about this camera that I bought, I told you I also bought a lens. I found out the lens, it's not needed. So now if the stream goes down, it means that my computer made kaboom. And it shut off. So maybe I'll connect it first to the power supply and see what happens there. No, actually nothing happens, which is not the best sign. Is it off? Oh, it's off. See, we have LEDs with the remote. The remote is RF, so it's no problem being inside the case. Let me zoom out. Okay, so let's try to connect it to the computer and see if we get image. See, this is a big wire, like big and soft, very soft. So I'm gonna share my screen now. Wait, let me just set these guys away. If I can get him in the box again, it won't be a easy job. Because I don't know how Chinese do their stuff, but whenever they send me something packed in a box, I can never get, if I take everything out, half of the stuff won't be able to get in again. I don't know how they do it. Some special skill that I don't have. Because how the hell was that thing there? It will never fit there again. And there's a thing I have there on the printer since, I don't know, I think it should have finished printing 10 hours ago, and I haven't even looked at it because I wanted to show on stream. Yeah, IKEA is the same, it's the same stuff. But usually IKEA, we don't need to actually... Jesus, how was that there on a single box? That's impossible. I barely can fit it in two. Well, it's fine. It's good enough. Usually IKEA stuff, soon as we unpack it, we don't need to pack it anymore, so we just need to assemble it. That's another thing, but... Okay, so let me put this here. Let me change the camera arrangement again. Just aim it there. Or maybe I can bring it here more. Yeah, I know we don't need the RGB thing, but we can press on W so it goes to white, and then we can set the brightness up and down. So yeah, that's fine. So let me take out my multimeter as well. So as I was saying, when I first spoke about the cheap camera, I said I also bought a lens for it, which besides do not work on this camera because it needs to be a pinhole lens, and I'm stupid and I ordered a normal one, but it's not needed anyway, so even cheaper. The price of the lens, it's enough to buy a good cable. Okay, and also I connected it to my computer and nothing weird happened. So let's see if it's working. So I'm gonna share the big screen. Yeah, there. So I have the app from Ember Prototypes in here installed. I'm going to bring it up here on this corner. Here we are. Let's see. Why doesn't it... Oh, start. No. Well, maybe... Let me reconnect it. Oh, actually I have a refresh button there. Maybe we have to open it after all. What do I want? Okay, let me try to add the camera here and see if it works. Oh, wait, maybe sometimes I have a problem that some USB 2 cameras don't work on my USB 3 ports. So let me try it in this side. I don't know why, but it's a thing on my computer. yes. Okay. It was my antivirus. Since the software needs to access the webcam, he needs to allow it. And why did my software didn't hope? Okay, so we have picture, kinda. So we can, okay, let me home the machine. Let me move the stealth press away. We shouldn't need it more, I think. Okay, so let's gonna give it some space. There. Let's put it under. Somewhere there. Should be fine. Looks fine. I know it's very... Can I make it bigger? Actually, I can't. So let's go closer to see if we get... Is it getting better? It's getting bigger. I'm not sure about better. Yeah, maybe it's too far. Well, let me check. We have still space, so... yeah, it's getting better. It's definitely getting better. We have a black hole. How does that look? That looks cool. So let me see. Oh, it's like almost. Doesn't that look cool? That looks fucking awesome. So now let's call... Yeah, we have space. Let's call the other tool. So tool 1. See? Spot on. Kinda. The other one wasn't perfect either, so... As you guys see, the sheep camera worked just fine. Let me increase the brightness to see. See? We have much difference in brightness. With the remote! Look at that. Who doesn't like that? A remote for the calibration camera. Okay, I'm happy with that. So I can give you the links if you guys need. And it works with the Ember prototypes. So let me aim the camera a little higher. So you can even use their software, which is free. So you don't need to use a ghetto OBS with a crosshair and whatever, and it's cheaper. I know the guys need to win their money, but like I said, for ordering $50 from America plus shipping plus taxes customs duties, whatever. This thing costs $6. The ring cost $4, I think, $10. The cable cost $3, so $13 for the whole thing, and we have fun we even have fun assembling it. A bit of CAD to design the box, and that's it. So, and since I'm gonna do the stealth changer, I have this machine and I'm gonna do the stealth changer on my 2.4. So I'm gonna be using the camera as well. So yeah, you can beat that. We can do even a bit of zoom. Actually a lot of zoom. So yeah, you can use the software to calculate the offsets. If you don't want to do it manually, that's fine. So yeah, move on. Let's move on. This works. Offsets are good. I used N52 magnets, so this actually grabs pretty sturdy. Could be better, but it's good enough, especially with the soft wire, which doesn't make it. You see, I can. Let me put it there so we have a reference. Where is it? Where is the nozzle? Should be there somewhere. There. And maybe if I remove the zoom. So I can actually move the wire and it won't mess with the camera, so it's good enough. So that's one more done. One more tool in the box. So let me open Fusion, which I should have opened already. Trust anyway. Let me I have it open on my other system. Doesn't matter, let's shut it down. So let me what? EasyCap? No, it's not EasyCap. What do I need? Should be this one. Yeah, that's fine. Let me do what? Move this light here to the side. forgot to. About the remote for the LED rings, if you guys buy it, it says it takes a CR 2025, but it also works with a CR 2032. Because I didn't have any CR. It doesn't come with batteries, and I didn't have any CR 2025, and I tried the 2032, and it works. Because the 2032 I used in a lot of my measuring devices, so micrometers and calipers and whatever, and I have a lot of them. So these can go, well, I can save this, because we never know when we need an USB cable, especially a bad one, but especially when I have a bunch of them. Okay, so as you guys know, I'm gonna build a Velta next, and actually let me share the Fusion screen instead. It's gonna be best, yeah. And the guys from the Velta haven't done a great work with CAD. Let's say they did just a good enough work with CAD. Barely. So, oh, actually, oh, okay, I didn't save. Shit. Okay, let me do something quick in here. Just while. Yeah. Maybe the main camera. Yeah, like this. Give me just a few minutes to prepare, because I forgot to save. I done this on my other computer, but it looks like I forgot to save the file. So just a few minutes. So I can prepare some stuff. Okay, let me set it. First, let me activate capture story. Jesus. Okay. My computer, it's not the best one for CAD software. It's a nice computer, it's a laptop, but it's old. It was very nice when I bought it, but now it's just old. Okay. So, rigid group. Yep. Okay. Let me bring it out. Up. That. So first you with you Now you with you, and now what? Oh, you with you. Yeah, that's fine. So let me shut it down now, and let me add the other guy. Where is the other guy? Ah, it's here. So I need to turn it here 180, and I don't know, something like that, 60 maybe. Okay. We need rigid group, chapter position. Okay. Now if I do this, come on, yes, and this, oh okay, makes sense, oh kinda, you with you. I know you guys aren't seeing what I'm doing, but I'm just finishing. Just few more seconds. Okay, that's fine. Okay, so fusion. Okay, so the guys, this is the Velta. I'm gonna shit. I did it on the wrong side. Well, it doesn't matter. It will be good enough for demonstration purposes. So these guys made these corners, and these corners have some straight things here. So these are supposed to print. Let me check. Let me disable the panels. Yeah, so these, it doesn't matter how they print. I think they print on this orientation here. Yeah, because we have cross bridges there. So it's supposed to print like this. And the guys didn't make any supports, and we are pretty much printing. If I do isolate, oops, no, not this. If I isolate this guy, can I do it here? No, but I can go here to the corners. Corner 1, top corner. So if I do, where is, should be able to do it. Yeah, should be able to isolate it. Why can't I? Oh, it's here, isolate. Okay, so as you guys see, it's gonna be a problem to print these. Actually, I didn't notice it until I printed, and so I printed a few tests just to test the fittings, and so this one was the first print I tried. Let me see if I can show. Oh, I can, but I need more light. Let me actually do this. Should be enough. Okay, yeah. So it's a mess there. See? Oh, it's not bad, given that no supports at all were used, but it's no bueno. No bueno. So I printed another one. This one, it's a lot better. I made some supports, but I modeled the supports, and it's a lot better. I can actually live that with that. Just a little mess there, but that's because of the seams. That was a slicing problem. I didn't notice where the seams were. So I did actually I have it here. Let me open there. Yes, I'm using Orca Slicer except for the Tridex because it doesn't work there. So I modeled these supports just because, well, why not? And I have a print there on the printer, which I haven't, because they designed this one, this red, it's also a support. And now I set the seams on Orca Slicer here. Actually, maybe I have the, yes I do, actually I do. So if I do here, yeah, so I set the seams here on the inside while they were something like there before, in this area there. So let's see. I haven't taken it off the printer yet. I haven't even looked at it. So it's on my V0. Well, it's not okay. Looks like I need to do supports in there as well. This one, it's actually good, but not this one. Well, it's not too bad. I need to get away. Let me try to turn off the top light for a bit. Need to get a remote for that as well. Let's see if it's better to show. Oh, actually it is. So it's not the best. Let's take out the support. So okay, it's a bit white now because of the stress marks, but if I give it with a 8 gun, the white stuff will go away. It's not too bad. This one, it's much better. Yeah, I think it will work. And this one, yeah, this one is fine. Of course, I have the Tridex. I can try to do close supports with PLA or EIPS and solve them, but that requires some testing. Yeah, I really don't like that one. Let me give it with the heat gun just for a bit. I need more power. Yeah, much better. Yeah, it's acceptable, especially on this side. So the fitting is about perfect. Like, just enough to hold the piece. The first one I did, actually it was a little loose, but this one, the first one was this one. There was not even enough filament to actually finish the piece, but it's good. It's like a slip fit, but it doesn't hold the weight. So yeah, I think we are good. Now I need to tune the final filament to print the parts. I already received it today. So one other thing I'm changing on the Velta is there is no screen originally. So let me isolate this guy. And I know this is the front part, but by mistake so let me hide this guy and this guy, and actually this guy too. So all my printers must have screen. It's a thing. So I modeled this one, which is on an angle. But since this is a tall machine, I believe this is something like, what, 60 centimeters high? Maybe more? Yeah, 61 centimeters. So it's gonna be like, I don't know, if I put it on the table, where is my tape measurement? And I will put it on the table. I will still. Test 1, 2. It's been a long time. Or were you listening? Because actually I wasn't checking my levels. It's weird because it wasn't charging, but I remember it was connected to the charger. Maybe it wasn't plugged all the way in. I think it was a pairing issue. Let me see what's going on here. Yeah, it was a pairing issue. Okay, thank you for heads up because I really didn't notice. But yeah. So were you listening before? Like, was I a long time without speaking, or you just tuned in and you noticed that sound was gone? So yeah, this stuff is beautiful, man. I really like. I'm not like a purple kind of guy, but this color, it's very, very nice. It's very cool. I'm not like into the pinkies and purples and whatever, but this purple looks awesome. I actually like the teal as well, but since Beanie is already doing a teal one, I'm gonna do another color. Maybe I'll use the teal on my Micron when I build it. Okay, so what was I saying? I don't remember. I think I was thinking about doing the tuning, the filament tuning, and I grabbed the spools and, well, whatever. It wasn't important anyway, I believe. So yeah, I was talking about the Velta about the skirts that I modeled to use a screen, and I don't know which model I'm going to use. I have a angled screen and a straight screen. So I was talking about that, but I'm going to print both skirts, and I'll decide when I actually make the printer, I'll decide which one I'm gonna use, because when we get to the screen part, we are pretty much, so I have the full assembled thing, and I'm gonna test it with which one will be better. I believe the angled one will be better, but I would like to use the straight one. Well, anyway, so I have another filament that I actually find very beautiful. Let me see where I put it. So this is Galaxy Dark Gray as well. What is it? Is it here? I have filament spools everywhere. So that's the green. Oh, it's here. Hey Nadir, what's going on? How are you, mate? Welcome to the stream. I also got this one, and this one will be hard to show. I'm gonna open it as well. Fuck it. Let's go. I haven't actually seen it either, so... So this is what I'm gonna use on my 2.4. This thing, it's very beautiful as well. So this is red with gold glitter, but the glitter, it's very fine. We can barely see it. It's not like the Polymaker. No, it's not. It's not very shiny. It's from the lighting. It's from my lighting. It's not very shiny at all. Well, it's shiny, but it's not very. But you can like that. You can see kinda the glitter, the gold glitter. This looks nice. I'm gonna use this on my V2.4. Black, Galaxy Black, and this one. This is from Filament PM. This is what? This is Scarlet Stardust. This is Filament PM. Probably you guys don't have this there because this is made in Czech Republic. But you guys have something close to this. I think that one that Steve used on Milo, it's actually very cool. But it's the same thing. It's red with glitter, gold glitter. But this one, it's the blinkies are very, very fine. I don't remember how it's called, the one that Steve have on his Milo. Ambrosia. Oh, okay, that's cool. This is good stuff. This filament is very good. Well, I'm gonna just put it away because I need to seal this and vacuum seal it, because otherwise it will get wet. ABS Scarlet Stardust, yep, that's it. Oh yeah, this is nice. Well, actually, I don't think the glitter is finer. It's just less than the Polymaker. The Polymaker has more glitter than that Filament PM. And they also have the green, which I have here. I ordered a spool as well, so it's the same thing. I'm not gonna open the spool. I can open the box, but I won't open the spool. That's the sparkling jungle. It's the same stuff, but it's green, and the green it's much beautiful than it's showing on the picture. It's like a grass green with sparkles. See you, Joseph. Thank you for the help. Thank you for the presents. And have a nice day. A rest of a nice day. Okay, so let me put these on the printers. I'm gonna test, since I'm gonna print on both printers. I'm gonna do the calibration on both of them on the same time. So I'm gonna use my trident to the main parts and my 2.4 for the secondary color. Should be the other way around, since the 2.4 has a bigger print area. But lately I have way more confidence on the PE sheet I have on the trident than the one I have on the 2.4, which I'm gonna change when I build the stealth changer, when I rebuild the printer. I think the problem mainly it's not even the PE sheet or the spring steel sheet or whatever. I think the main problem is the actual bed, which I'm gonna change as well. Because I think the problem is the heat pad, the silicone heat pad on the bottom of the 350 bed of my 2.4, it's too small. So I get a nice hot bed like in the middle, but the 5 centimeters on the edge, on all the edge, it's colder. So I have problems of adhesion on that area. Now I'm gonna make a new bed thicker, so it has more to have more heat soak. And I have a larger heater. Actually it goes to the maybe this one, it's like 3 centimeters or even more shorter on the edge, and that's the silicone we see. The actual resistances inside are even smaller. And this new one, I think I have it here so we can check. I think it's actually the size of the so this thing is 1000 watts, which is insane. And you see it has the spaces for the the screws. Yeah, this thing is actually, so the bed is 355, this thing is 350. So it's like 5 millimeters shorter than the actual bed. And we can do a thermal analysis because I have a thermal camera. So we can do actually a thermal analysis of the where do we have actually resistance here near the edge. So yeah, I think this will be much better. This was expensive. I'm not sure exactly how much this cost, but it wasn't cheap. Well, compared with the original ones. Jack, I don't know if you're there. I'll ship your stuff on Monday. I received it today, but tomorrow I won't be able to. I won't be able to ship it. I'm pretty sure I'll try, but I'm 19% sure I won't be able to. So I'll ship it on Monday. Okay, so let's get into, okay, I think, let me purge, yeah, let me purge the filament. This thing is hot already. No, not print, extrude 25, 5, extrude, close, extrude, load. So this one it's fine. Retract, temperature 120. And this one, load one more. Come on, load. There we go. Okay, retract 120. Jesus, my dog, it's on fire. What does she have? Let me check. It's communicating with his friends. Okay. So ideally, first thing we should, well, when we are tuning a printer, the first thing we do is the extruder rotation distance calibration, but we've done that already on the Tridex. And actually I'm not using the Tridex, but you guys seen how I did it. So it's basically you heat your nozzle pretty hot. If you're like 20 degrees higher than the filament you're using, or you can remove the nozzle. So the idea is to extrude 100 millimeters of filament, and it actually extrudes 100 millimeters of filament. So you do it slowly. You do it, make sure the nozzle is quite hot. So you want the least resistance, the better, because all you want to do is make sure that you're telling the extruder to extrude 100 millimeters and it extrudes 100 millimeters. If it doesn't, you adjust according to the formula. So you see now I did it. I used the ruler on top of an extruder. I used a piece of tape marking 150 millimeters. Then I set to extrude 100, and I checked the remaining and adjust accordingly. So that's the first thing you do to calibrate the printer. Some people calibrate E-steps for the actual movement. I don't do that. So if you use good pulleys on the motors, only the motors, that's what matters. If you use good pulleys on the motors, you use good belts, it's going to be fine. A turn of a motor, it's 20. So it's the pulley has 20 teeth. The belt is 2 millimeter pitch. 2 times 20, 40. Nothing else to do here. So the rotation distance of both A and B, 40. I don't mess with that. So, and I get good prints. Now, next thing, I follow the Ellie's something from Warren print forward thingy. So he's basically the guy, one guy off the PIF. That's the printing team from Warren. If you buy printed parts, let me. If I can see shit with the reflection. So what is it? This guy, the Ellie's print tuning guide. So basically I follow this guy. So next thing you need to adjust, it's basically the Z offset. So the squish thingy. So that one, it's actually, I'm not gonna do as well because I did it already. It's kind of trial and error. So you've seen me actually measuring the offset of the Z probe. Then you just, when you do the first prints, you adjust with baby steps. And then after the print is finished, you just save the configuration, you're done. Nowadays we have probes that do meshes and whatever, so it's not really, it's not a big deal nowadays. I remember when there was no such thing as bed probes, we need to do it all by hand, but so let's see. Yeah, first layer squish. Yeah, you can follow this guide. I'm gonna put the link in the chat if someone needs. Just search for Ellie's print guide or print tune or tune guide or whatever. Google gonna get you there in no time. So if you read this carefully, everything is here. So what I find very important, it's actually these two. Well, it doesn't even say in here. This is quite old as well, so it's a little, it's not outdated, but old-fashioned. It's like old school. So back in the day, we usually just check. Well, people already been a while since they do pressure advance specific for each filament. But at least when I first built my 2.4, it was kind of a default thing. Nowadays you can even set it on the slicer, so when you select the filament you're using, you already you can define already. Oh, I'm gonna be sit for a while, so let me lower the camera. So you already have defined on the filament on the slicer your PA value. So first, I think I'm gonna do a calibration tower, a temperature tower, temperature calibration tower. I'm not even sure. Let me. What is it again? I need to get a shortcut. So if I go here on Orca, on this one, so I'm gonna use my Trident B. So when we go here on the filament profile, we already have pressure advance in here and the temperatures and whatever. So now I'm gonna do a profile, a new profile actually. So let me grab like ABS 2.4. So I'm gonna create a new one. So it's gonna, no, actually I have the Polymaker here. Yeah, I have the Polylite black. This one. So let me put here. Boas, Bini. So this is my profile from the Polymaker Polylite ABS black for my V2. So I'm gonna change these to purple because I'm gonna set it to purple. I'm gonna set this to 97. Or 6. I don't know. Yeah, I'm gonna set 96. It's just because I kinda have this settled down already, but okay, so I have 250, so I'm gonna do no, I haven't tried it yet. But I did actually made my own supports. I showed it already, but I'll show it to you. So I did a test print with my own supports. I did some I modeled the supports. I'm gonna try this one now. See, it's much better compared to Jesus, this is weird. There. See? So this is the bad one. This is a little ugly next to the hole, but if I put it like this, but it's much better than this one. So yeah. Okay, so let's see. I'm not that an expert yet on Orca. I've been using it for a while, but I haven't actually. Yeah, no problem, man. So we have temperature. So ABS. Nah, we're not gonna do so much. We're gonna do like. So I have a base temperature of 250. I'm gonna try 235 to 260. And okay. Jesus, that scared me. What's that? Object. Fuck off. Oh, sorry. Since I was big screen. Okay, sorry. Actually, Orca. Why? Uh, okay. So what I did, I'm gonna do again. I'm gonna delete this thing. Let me go here, make sure. Yeah. Okay, so basically we're gonna do to calibration here on the top, temperature, 260, 230, 235. I don't care. Discard. What's this? Maybe transfer? Transfer. Well, let's see. Like I said, I never used the Orca to do this. I've done it many times on Super Slicer, but lately I just go and deal with. Yeah, 255, 250 sounds good for ABS. Let's try it. Oh, the print went well. Fine. If I see, maybe it's a little stringy or a little, the hangovers are not very good. Okay, I'm gonna go with, I'm gonna lower like 5 degrees, up 10 degrees. Let me just check the fan cooling. Let me see what I have here. So no cooling for the first 2 layers, full fan speed at layer 6, sounds good. Mean fan speed 50, yeah, that's fine. 10 seconds, yeah, maybe lower. Well, let it be. Since I'm gonna print slower. Now let it be like that. Sounds good. Sounds good. Okay, let me close. And let me send it. Where am I? Let's slice it. Why didn't it change? Okay. Well, actually, I should. Let me set the quality 2.2. Transfer. And slice plate. Yeah, it can do a brim. No problem with that. So these, how long will this take? 1 hour? Nah, can't we? That's too much. That's too much. Let me go here because I can't wait 1 hour for this test. So cooling. Yeah, the problem here. No. There's no way I'm gonna wait 1 hour for this thingy. Well, maybe I will. Maybe I will. So no, I'm gonna do one other thing. Let me go here, prepare, delete all. I'm gonna do a smaller interval, like calibration, temperature. I'm gonna go 240 to 255. So the problem is somewhere here on the speed. I don't know where. No, it's not here. Others, let me check the others. It should be on filament. Maybe I'm blind. Let me check again. So it should be here. So this is when the cooling layers. This is the speed for layer time. We can do 40 here. Keep fan always on, slow printing down. Okay, yes, that's the thingy. So let's do minimum 60. I don't care. At least for now. Okay. And I'm gonna delete because, and I'm gonna do another temperature. Okay. And slice. And 41 minutes, that's better. Print. And upload and print. Okay, now I'm gonna do prepare. I'm gonna delete this. And I'm gonna do, actually I fucked up. So this one is actually the gray. Let's put this gray. Oh, and I forgot to change the, well, fuck. To change here to dark gray. Whoa! Didn't I select the gray? Yeah, this one. Save. Okay. Yeah. So, and now I'm gonna do purple. Okay. Gonna save. Same settings. Purple. I usually use the same profile for the Trident and the V2.4. Works fine. Usually. Same PA. So for now I'm gonna leave it. So let me select the 2.4, 0.4 nozzle. Quality. Okay, I need to strength to check. Yeah, it's fine. Quality. So I'm gonna do no, not preview. Calibration, temperature, same thing. Okay, I need to change here the. So first let me. Fuck. Okay, let it be. On my V2, on my V0, I need to change the PA. The PA needs to be much lower, not much lower, but enough lower to take to make a difference. So yeah, the purple one. Purple. Sure. Okay, so that one is printing already. Let's open. Let me open just to check it. So that's the what? This one. Let me open the other one, which is the 201, I think. Yeah, let me go check just to make sure it's fine, I'm sure. Well, actually it's not. Well, it doesn't matter anyway. It's too low. Yeah, it's fine now, I think. Doesn't matter. The offset, it's a bit too low. Well, the only thing I need to change it's the PA, and the PA it's an extruder thing, so that's nothing I can do there. I could set a macro to like do an offset on the PA, not a macro, an automated thing, but nah, I just select the right filament for the right printer and YOLO it. Okay, so yeah, I'm gonna delete calibration temperature. Okay. Slice. And print. Oh no. PA you can set it on the filament. If you go here, the PA is not it's not always the same. See here? It's the same. You can have the same filament, same brand, different color, and the PA is different. It doesn't need to be an ABS and PLA thing. You can have filaments from the same brand, different colors, and change the different PA values. Some people, like the really nutty ones, even every new spool, they do a PA test. So those crazy people, which I won't say any names, but I know people that do that. Not for me. Yeah, me too. Usually between 0 on the big machines, 0.04, 0.045, and on that one 0.03, 0.03, 0.035. Usually 0.03. It's just yeah, me neither. I'm just doing this to show that it can be done and it should be done, not that I do it. But sometimes when I do specific stuff, I really need to set the right thing. When I need sharp corners, well, sharp as 3D prints can be, I need to adjust that thing. Especially when I'm doing printer parts. Sorry. When I'm doing printer parts, I actually dial up the stuff to, especially when it's the extruder or the head part, which needs to be a little more sensitive. I'll do the fine tuning, everything as it should. Or when I'm doing little gears that need some precision or some stuff like that. Other than that, general stuff, yeah, YOLO it. 0.04. I haven't even for PLA, since I only do like toys and stuff in PLA. I don't even care. It's the same value as ABS, and I don't care. But I don't print PLA anyway, unless I only print like dragons and fancy stuff. So I don't even care about the values. Okay, actually, 255 doesn't look too bad, but it's a little stringy. Well, my nozzle, it's very dirty as well. It's not too much, but it's gonna be 250. 250, it's a good temperature. Pretty sure. From what I'm seeing there. My camera is on the V2. It's all fucked up. She doesn't like heat. She it wasn't a problem until like, I don't know, a month ago. It's a small Pi camera, one of those that connect via the flex cable. The not DSI, CSI, I believe. Yeah, because it's the camera interface, so it's the CSI. The display port is the DSI. We can see the age of the machine just looking at here. See, only 4 temperatures: raspberry, chamber, heater, and extruder. When you go here, you start to see the technology advancements. I need to check this one because she's old and it's a bit. No, actually, it's not. Yeah, it's fine, it's fine. She's old, but she's good. The Tridex then, it's like a fucking phone book of temperatures. I imagine when I held when I have still changed it on that thingy. It's gonna be like yeah, yeah. I have a BTT Pico on my V0 and I'm strongly well actually well I can't. I can't. I was thinking about taking it out and putting it on a belt. Actually, I need to order a fucking Raspberry Pi for the Velta. I have a tree there. I can use that. But I was saying I have one on my V0, BTT Pico as well. No, I meant yeah. I was confusing the BTT Pico with the BTT Pi. Well, the I have one here. Let me see. What is the BTT? I have the on my V0. I have the Pico, and it's good enough. It doesn't have space for for a chamber temp. Well, if you put CAN boost on it, it has. Oh, okay, mine has because I have it on the edge PCB. Since I have the LDO umbilical. What is my? No, it's not here. It has to be in here. Yeah, it's here somewhere. Yeah, it's there. So let me check. What do we have here? Well, probably I won't be able to see anything in here, but we can check on the... Let's see. What do we have? What's this? So we have Fun 1, Fun 2, Fun 3. So we have... Yeah. Thermistor Beth, Thermistor Adam. XYZ stop. Well, actually, um, are you using end stops or sensorless? Well, maybe you can use I'm not sure if it's if the end stops are all digital inputs outputs on the Pico. Maybe you can use a thermistor on one of the end stops. Let's check. You can't use that. I don't think so. I think you can define the oh, okay. If you try that, so whatever. What about E0 stop? The one that's on the side of the RGB. So IO16. We all need RGB, so that one doesn't. We can't even think about that. So what about these? What are these? You have the filament detector. Well, you have the. There's. Oh, no. That's another stuff. What's this? You have the probe to try. You have the laser. The laser should be PWM, so maybe not. Maybe it's not a good idea. We have the servo. Plenty of stuff to try. Yeah, all good, Beanie, all good. I won't be much more either. I'm gonna finish that, do a PA, and pretty much, let me see what's the printing tuning saying. So yeah, the pressure advance. Sure, man. Cooling in layer times, that doesn't matter. Retraction, doesn't matter. Um abraço, Bini, boa noite, porta-te mal. O Cristiano e o Simão é que andam muito calados. Já devem ter ido dormir. Eu também vou breve. So... Step over. What the fuck is step over? Yeah, extrusion multiplier, that's important. Do we have tests for that in here? Let's check. So Orca has quite some good stuff. Let's see. So yeah, flow rate, yes, pass 1, pass 2, pressure advance, retractions, tolerance. What's the Orca tolerance? Let's see. What's the... Ah, most likely that thingy should fit Do we have information on that? Tutorial. Copy. Okay, arco tolerance test. Oh, okay, that's cool. Okay, so that's fine. So basically we have all the tests we need here. So we have the temperature tower, we have the flow rate. So that's the extrusion multiplier. We have the pressure advance. We have the retraction test and the arco test. The tolerance test. So yeah. So this one's supposed to be to fit M6 sorry, an 6 millimeters Allen. It should fit on either the first one or the second one. Then it goes, the further it goes, the worse it goes. That's cool. Yeah, maybe we'll do an arco calibration full testing. Yeah, because that's pretty much all you need to do. You need to do the extruder rotation distance. You need to do the temperature for the filament, the flow rate, the pressure advance. That's pretty much everything. Retraction, it's like, maybe I think it's more important on the Bowden setups than actually on the direct drive. Because the direct drive, you set like a retraction for 1 millimeter and you're done. Or even 0.75 millimeters. Yeah, let's see how so this one is almost done. I actually want to leave the printer's printing parts for the Velta because I really need to start it. Maybe I'll start it on, I don't know, Sunday after lunch, like 14 p.m. Should be nice. I think I have everything already for it. Maybe yeah, I think I have everything. Even the cameras arrived today, so let me go check how stuff is. I'm sorry I can't show you because I would need to move. Okay, so for the purple, 255 seems too much. 250 looks decent so far. Maybe 245 would be the Yeah, 245 probably it's the best for each one. It looks like. We'll see. So let me check how is the pressure advance. Okay, let me first delete this guy. Pressure advance, so PA step. No, that's too much. Yeah, that's better. So this should be, yeah, this will be a macro. Because when we do some, yeah, that's it. So this is just lines. This is a fast test. So this is 0, 0 0.05, 0 0.0. Okay, this is a good test as well. It's fast. It's simple and it works. Let me check how is the flow rate. Okay, so it's basically a minus 20 to plus 20%. So it starts at 1, at 0, let's say. So it's here it's 1, here it's 105, 110, 115, 120. Here it's 95, 95, 90, 85, 80. That's fine. It's kind of too much of range, I would say. Let's see PES 2. What do they do at PES 2? Flow rate PES 2. So why? Okay. So first, on the first one, probably we need to set the filament, the multiplier to 1. Let's see what they say on the calibration, on the tutorial. So flow rate. Printer for the test. Select PES 1 in the calibration. Yeah, okay. So it's according to the value. So if we don't select anything, the 0, yeah, okay. So we have 0.98 and the 0 it's good. So we are bang on. So it's the 0 or the 5. You don't know which one is better. It's probably in the middle. Yeah, that's fine. Okay, that's cool. So what else? What do we have more? Let's delete. Pressure advanced. Let's see how is the retraction. Probably 2 towers. Ah, fuck that. 1 steps. Yeah, 0 point. Sounds good. Transfer. Yeah, it's 2 towers. And it just... Okay, that's fine. What more? Yeah, we've seen it all. So how are we? 70%. Let's see, how is the 17%? Oh yeah, 245 seems like a sweet spot. Well, actually 250, I don't know. That's the problem with this test. For me, it's always the same. Everything looks the same. I should have cleaned the nozzle before. It's a mess. Yeah, the 245 looks very nice. And let's see in here on this, on the purple. Purple can't say yet. Yeah, turned off this one. Well, I think I'm gonna end the stream. No point of being here without doing anything. We did some cool stuff, and maybe I'll do a dedicated stream for calibration one other time. It was fun. So, well, let's let one finish. It's like, what? 8 minutes left to finish the gray one. So yeah, maybe I'll start Yeah, I'm gonna finish. I'm gonna finish. Yeah. Well, thank you, Jack, for the main. No, not main. Front. Thank you, Jack, for the presents and the company. So yeah, it was fun. I had some fun. I was very glad that the camera worked out. We finally fixed the Tridex macros. Seems fine. I'm gonna leave it printing a dragon tonight. A dual color dragon. Should be fun. We fixed the we assembled the camera, we did some calibration, we talked about the new project. Yeah, so thank you for watching, everyone. I'm getting tired as well, so I'm just gonna leave the printers printing because I'm pretty sure the settings are fine. So yeah, thank you for watching. I hope you liked it. If you have any questions, please just post on the comments. I want to thank again to Lab 4450 for the support they gave me. They are not giving me actually support on this particular stream, but we have some good stuff coming out. So thank you for watching and hope to see you soon. Hopefully on Sunday. I'll keep you posted. Bye bye.